Let's go ahead and take a look at 5.428 and 5.441. These are similar to your online homework problems here. And so in this case here, conditional probability plays a role in the calculations here. What's the probability that both sodas are diet given this situation? 12 of them out of the 36 have diet soda in them. And it's the probability that the first one is diet times the probability the second one's diet is 12 out of 36. It's a 36 pack. 12 of them are diet. By the time you get to the second one, we already know the first one is a diet. So now we have 11 diet sodas left out of 35. You multiply that, and that's where you get your 0.0148. Determine the probability that both contain a regular soda. And so it's the same thinking. The first one's regular and the second one. So you can see your calculations here. 24 out of 36 times 23 out of 35. And so you end up with your 0.4381. Again, it's because there's conditional probabilities. The probability of the second outcome depends upon that first one. It's been altered or updated because there's a dependence. They're not independent events anymore. And so would this be unusual in this case? No. This one's a little bit trickier. The probability of one diet and one regular one regular soda would be this. There's two situations. The first one can be diet and the second one regular, or you can have the first one regular and the second one diet. And so to do those calculations, it's an or situation. You have both situations, this one or this one. And so when you look at that, you get 12 out of 36, 12 diet out of 36 times 24 regular out of 35, because now we're at the second can of soda. And then 24 out of 36 times 12 out of 35. And so that's where we have those numbers come from. Multiply, add, and you get 0.4571. Now let's take a look at the second situation. It's calculating conditional probabilities when you have a tables of values, when you have these different values here. And so here's the formulas we used earlier. The probability F given E is the probability of E and F divided by the probability of E. The second formula is where if we have the numbers instead of probabilities, it's the probability F given E is the number, right, the frequency of E and F divided by the frequency of E. N again stands for the number or the frequency of these situations. And so in this case, the probability of being less than 18 years old, you look at this table, we have a total of 82,466 out of the 343,000. And then in this situation here, what's the probability less than 18 given you have no health insurance? And so there's your F and your E. And so in this case, we're going to look at the numbers, the frequency. So how many are E and F? No insurance and less than 18 years old. There's your no insurance. There's your no insurance and you're less than 18. So you can see the 8970 is what goes on the top, divided by the number of frequency of E. E is no health insurance. And so there's your 52,580, and then you divide those two. So that's how you would calculate these given probabilities when you're looking at a table of values and you're looking at the frequency values. And then we know that these are not independent events because the probability of the first one is not equal to the second one. If they were equal, then we know they're independent. But since they're not equal, having your type of insurance does influence are connected to your age, right? There is some dependency there.